Hello, ninth grade. This video is to help you with practicing orthogonal vectors or using the dot product. So this first problem, we need to state whether the vectors are perpendicular, parallel, or neither. And so we're going to apply the dot product to each vector. So looking at the vectors in A, we have 4, 3, and -9, 12. The dot product between the two would be 4 times -9 plus 3 times 12. And that arrives at -36 plus 36, which is 0. So they are orthogonal. Now in vectors B, we have 40, 56, and then 5 and 7. Notice all these values are positive. So this should tell us initially that they're not going to be orthogonal. Remember, using that slope idea, one has to be negative, one has to be positive. So if we take the dot product, we have 40 times 5 plus 56 times 7, and we know that will not equal 0, so not orthogonal. But maybe they're parallel. In other words, 5 times some k should equal 40, and 7 times that same k should equal 56 if they are parallel. And notice what happens when we do that one step. K is equal to 8 here for the x components, and k is also equal to 8 excuse me, for the y components. So they are parallel. Now in letter C, let's find their dot product. Notice we have 2 that are negative. So we have 3, -2, and then we have 18 and -6. Their dot product would be 3 times 18 plus a -2 times a -6, which is not 0, so not orthogonal. Oh goodness, I did that whole example without you being able to see. I am so sorry for that. I know that I do that frequently. So not orthogonal. In letter D, we have -72 and 48. And also think about what their relationship is. 3 times something gives us 18. -2 times 3 gives us -6, but 3 times 3 is 9, not 18. So this one would be a neither. Forgot to finish that piece. Keeping going in D, -72 and 48. The other vector is 7 and 12. Their dot product, -72 times 7 plus 48 times 12. So here we get -504 plus 576. Which equals a dot product of 72. So not orthogonal. And 72 divided by 9, let's see. 7 does not go into 72 evenly, so it would be a fraction. And 12 times 4 is 48. So there is no common scalar between those two vectors. So they're neither perpendicular nor parallel. Now this last example, we need to think of vectors that are orthogonal to the given vectors. So if we look at A, We have negative 4 and 0. What we want is two numbers when we add them together to equal 0. So if we called them, say, x and y. So negative 4 times x plus 0 times y has to equal 0. Well, think about this. It doesn't matter what y is, because 0 times y is 0. So really, we need to solve for this x. Negative 4x equals 0. So that tells us that the x component has to equal 0. So one possible vector could be, let's pick a number for y. Let's say 10, because it's the October. So negative 4, 0, and 0, 10 are orthogonal. And we're going to show this. We're going to do the dot product. Negative 4 times 0 plus 0 times 10. And that's 0 plus 0, which is 0. So that proves that our vectors are orthogonal. I'm going to do one last example looking at letter C. Let's find a vector that's orthogonal to letter C. And keep in mind, there are many, actually an infinite number of vectors that are orthogonal to any one of these. So answers will vary. So let's look at vector C. And again, this is the date. And this is orthogonal vectors. Doing some practice. Now in C, we have vector negative 11 and 7. So following the dot product, let's say our other vector is A and B. In order for them to be orthogonal, we need negative 11 times A plus 7 times B, and that needs to equal 0. So one way to think about this is using the numbers that you have here. Notice this part is negative, so let's keep this part positive. And so both A and B need to be positive values. And what about negative 11 times 7, and then plus 7 times 11? Using those and changing the sign and reversing them. And this would be negative 77 plus 77, and that equals 0. So this vector, so the vectors negative 11 and 7 and 7, 11 are in fact orthogonal. I challenge you to look at the other two and find orthogonal vectors and prove it by doing the dot product and showing that it is equal to 0. Thank you for watching.